Okay, we have this solo growth model, and on the surface, it might look kind of complicated because, after all, it seems to involve 6 equations, and that's pretty hard to wrap your mind around. But it turns out that we can combine these equations to get an expression that just involves the per capita capital stock. How are we going to do that? Well, first we note that savings is just equal to some constant fraction of output. And that output is just equal to, remember we've put everything in per capita terms, so that output is just equal to total factor productivity times the per capita capital stock raised to that parameter alpha. Okay, and then what we note is that goods market clearing, down here equation 12, implies that everything that gets saved gets channeled into investment and therefore becomes new capital goods. So savings equals investment. That then allows us to replace investment here with savings, but that is just equal by what we just did to something that is the savings rate times TFP times K to the alpha. So now equation 11 completely summarizes everything that's going on in the model. We have what is called a difference equation in capital. So I've just rewritten that difference equation here in 13. And what this tells you is if you start with some capital stock today, 1 minus delta of that capital stock will not depreciate because delta is the fraction that does depreciate. So 1 minus delta times the capital stock is the amount of capital that you're going to have left over next period. And then this object here is just investment, right? It's the savings rate times output. So this is new capital goods. So what we have here on the right-hand side is we have the undepreciated old capital, and then we have the new capital. And that then becomes new capital next period. Now, because we have a population growing, and we've written everything in per capita terms, we have that the population growth rate appears here. That's what the 1 plus n is. So we can just divide through by 1 plus n, and we get this expression. And this is called a difference equation. And it tells us how the capital stock evolves over time. And what we know from the previous set of equations is once we know what the capital stock is, we know everything, we can derive everything else from these equations. Once we know capital, we know what output is. When we know output is, we know what savings is. We know what savings is, we know what investment is. And once we know that, we also know what consumption is. So we're done if we can solve for the capital stock. And that's what we're going to do. Now, if you look at equation 14, it's natural to ask yourself, well, is it possible in this economy that the capital stock will just grow forever? And therefore, output will just grow forever? And the answer to that is no. And the reason is because capital exhibits diminishing returns. So in this sense, it is exactly analogous to what we were doing before with labor. Labor had diminishing returns. That meant that as employment rose, the marginal product of labor would fall. And that's exactly the same thing that's going to happen here. As the capital stock rises, the marginal product of capital will fall. And at some point, capital is going to just be replacing the depreciated capital. And at that stage, the economy gets to what's called the steady state. So let's just see that in this graph. This looks a lot like the graph that we've seen already, except instead of labor down here, we have capital. But up here, we have output as always. We have the production function, which we have written as zk to the alpha. Before, you remember, we just wrote something rather generic. We just wrote a general function f. And now we're writing a particular functional form. That's all, the only difference. And what does this say? This says that as the capital stock rises, and each increment from K1 to K2 to K3 to K4, I have rigged to be equal to 0.05. So as capital rises by 0.05, we can then look at this production function and ask, well, what happens to the increase in output? And initially, when output goes from Y1 to Y2, it rises by 0.096. Then in the next increment, it rises by 0.069. And in the third increment, it rises by 0.055. So what is going on here is shows up in these tangent lines, which are just the marginal products of capital. And what you see is that as K increases, the marginal product of capital declines. So these tangents become flatter and flatter. So a steady state then is just a condition where, the steady state is when K and therefore Y stop growing or shrinking. Okay, so a steady state of the economy is just going to be where the capital stock is constant. If the capital stock is constant, then output is constant, investment is constant, savings and consumption are both constant. And that's what we'll turn to next.